Okay, so our chapter 21 notes part 2, we've already done our type 1 and type 2 error, but today we're going to learn what the heck is this thing called power. Power, and of course there is a song for that, and I'll play that for you at the end. Okay, so but let's look real quickly because we just went over our type 1 and type 2 error songs. So let's draw a picture of it. First, type 1 error. So on this page 20, type 1 error is happening when what? If the null is really true, but we get a sample. Okay, so we have a true null. So that means our data is here. So our data is centered around our true null hypothesis. Oopsie, hold on a second. Okay. All right, there's our data right here. So we have samples all over this place. We do have some up here. In fact, they're all over the place. Okay. So let's draw in our alpha. Okay, so let's say our alpha is 0.05. That means that in fact, 5% of the samples that we could get are legitimately, valid, and they're going to cause us to what? Reject the null hypothesis, even though we should not. Hey, girl, what does it say? Why are you rejecting me or something? I don't know. I shouldn't have rejected you. Okay, there you go. Hey, girl, I shouldn't have rejected you. Okay, so yeah, so you got one of these samples up here. I mean, they're for real, and I should not have rejected you. Okay, cool. So guess what? That means whatever the size of alpha is the proportion of samples that will lead you to reject the null hypothesis, even if it's not, if it's true. So if the null is true, you're going to have alpha many samples that will lead you to cause a type 1 error. So in summary, alpha is not only the size of the rejection region, alpha is the probability that a type 1 error occurs. So if alpha was 10%, how much data up there would cause you to reject the null hypothesis? If alpha was 10%, how much data would cause you to reject the null? The top 10%. Then you had a bigger chance of a type 1 error. So whatever the size of alpha, that's going to be your probability of a type 1 error. All right. Good deal, because that's the proportion of samples in the rejection region. Okay, alpha is going to be the proportion of samples in the rejection region if the null is true. Okay, cool. All right, so now let's go on to the type 2. We had just sung our type 2 error. The thing in the song I typically hang on to is I fail to reject a false null hypothesis, type 2 error, type 2 error. So that's the part that generally resonates with me. So here is our null hypothesis. That is where the data is claimed to be. However, for a type 2 error to occur, the data is not there. So this is the claim, but not reality. Okay, that is the claimed data, but not the reality of where the data is located. Where is the data located? Somewhere else, and we're going to say it is centered around HA, wherever that is. Okay, so our data is here. And we're actually going to spend a lot of time on this picture, so I do want us to take a few moments to put a lot of p-hats in here so that we can see all of what's going to be happening. So let's put a bunch of p hat samples in here, all in our HA distribution. Okay, so of course these are proportion samples and so on. Okay, so there's our distribution not being HO. Okay, so let's go ahead and put our alpha in because that's where the rejection region would be. Okay, and I'm going to purposefully not put it right there in the center of that. So let's put our alpha in here. So here's, if the null is true, here's where we think all the rejection region is. But actually, what all samples are going to lead me to reject the null hypothesis? Like all of these things anything to the right of alpha is going to lead me to reject the null. Okay, so here is the next question. And we're going to have the odds tell the evens or something. So everybody's going to have to think, and then I'm going to roll the dice, and we'll see who has to tell who. So, who has to tell whom? I don't know which way it goes. So, type 2 error means that we did what? We failed to reject a false null hypothesis. Type 2 error, type 2 error. Why reject the null? Why reject the null? So we got a sample that led us to we failed to reject the false null hypothesis. Okay, so I would like for you to think, where are those samples that we failed to reject a false null hypothesis? And the odds are going to tell the evens. Okay, so do that now. Where are the samples that would be the type 2 error samples? You're going to fail to reject the false null hypothesis. There it is. There's a question. What samples would cause us to fail to reject the false null hypothesis? Okay, where you go? Where are they? To the left of alpha. So whatever proportion of samples are down here to the left of alpha, they would give us, we would not have evidence. No evidence. I get no evidence. No evidence. So I would fail to reject a false null hypothesis. Type 2 error, type 2 error. Okay? And just how alpha is the probability of type 1, beta is the Greek letter to represent the number that is the probability of type 2. Okay, beta is the number that represents the probability of type 2. All right, now I'm going to show you something that we want to know. Actually, you know what? I want to go over to your homework for just a minute because I want to put this importance of all of this into context. So take a look at your page 18. We're just going to look at the first problem. So this first problem is about if the company is discriminating against minorities and women in their hiring processes. Okay, so the null hypothesis, there's no discrimination because they're hiring at the same rate of minorities and women that applied. Okay, so here we go. Type 1 error was when if the null is really true, so there is no discrimination, but we get a sample that caused us to reject the null and think discrimination was going on. So what's a consequence that could happen because of that error? Yeah, lawsuit. So a group the NCAA or whoever it is that does their thing comes and does a lawsuit against the company for discrimination. Okay? So at that point, who doesn't like that? Who doesn't like this type 1 error? The company, yeah. So the company wants to really avoid a type 1 error. Okay? So that means they would want the probability of a type 1 error to be lower. They want to reduce the probability of a type 1 error. Based on what we just learned over here, how might they consider reducing the probability of a type 1 error? By reducing alpha. Okay, that's cool. Yeah, and so yes, alpha is a default at 0.05, but the researchers can set that, or whoever's paying for the survey can set that. Maybe if the company's paying for the results, they set it at 0.01. That's right. Okay, so now let's go back and look at type 2 error. Look at here at type 2 error. Type 2 error. Okay, the company is really discriminating, but we did not get evidence to detect it. So then minorities and women are getting screwed because they are being discriminated against and we're not being able to detect it. So who doesn't like a type 2 error? Yeah, the people, the applicants do not like that. So consider this. What if you are the company and you are paying for this and you say, okay, and the survey person gets a p-value, they get a sample and they get a p-value of 0.067. Well, look what happens if the company used an alpha of 0.05. What would be the result with a p-value of 0.067? You would fail to reject the null hypothesis. You do not reject the null. Okay, let's think about what did the null hypothesis say? The null hypothesis said no discrimination. So at the p-value 0.067, we had no evidence of discrimination. And so then the company's happy. They do not get sued. All's good with the world according to the company. Okay? But what if somebody comes in and changes the game and says, hey, we're the ones paying for this survey. We want to really be able to detect if the company is discriminating. So we're going to make an alpha of 10% so that the top 10% of data would reject the null hypothesis. Well, let's have the same p-value, 0.067. Use an alpha of 0.10. What happens now? Reject the null hypothesis that says P1 equals P2. The null hypothesis says no discrimination, and then we say we have evidence of discrimination. Let's take them to court. Dun, dun, dun. So do you see what control the effect of defining the alpha has on the conclusion? It totally changed the conclusion. So that is what I want you to realize today is, yesterday was just definitional, knowing what type 1 and type 2 means. But today is the importance of what the researchers and the data analysts and the people paying for the research and the data can do to the conclusion. They can manipulate it how they want. Okay, so therefore we are very interested in what things change type 1 and type 2 error. So let me just show you this picture real quick. Let's see here. Okay, let's put the alpha down a bit into the middle. Okay, so take a look here. And the blue area is our rejection region. That's our alpha. This is demonstrating a two-tailed, so it's there. Okay, so there's our rejection region, and then so there's our alpha, and then what's the the peach area, the orange area. This over here to the what? That was our type 2 error probability. That was our beta. Okay, we just did that. Watch this. Okay, watch this picture as I make alpha get bigger. Here we go. What do you think is going to happen? Before I actually move it. Okay, yeah, so alpha goes up, so type 1 becomes bigger. What's going to happen to the peach? You think, well, let's see. Here we go. Let's see if we can tell. Here we go. It's delayed reaction. Okay, so what happened to the probability of type 2 error? It went down. So in summary, what's happening, and we're going to actually write this down here. We're going to start a little memory device. We know that our type 1 error, this is back on page 21, I think, is the probability of a type 1 error is alpha, and we put that in a circle. The probability of a type 2 error is beta. We put that in a circle, and they are inversely related. So as type 1 error increased, what did type 2 error do? It decreased. So if I reverse the arrows, then it would be the flip. They're inversely related. This seems kind of simplistic right now, but we're going to add to this picture as more players come into the play. Okay? In fact, that's what we're going to talk about next. Power is the new thing for today. And I don't even like this word ability. Power has a numerical value. Power is the probability to reject the null hypothesis if it is indeed false. We have to know that in our hearts. In 2018, one of the problems on the APFRQ was involved a question, and the answer was power. And people didn't know the definition of power, and it had never been on a test before. And so, therefore, the average score on that FRQ was out of 4 points, 0.7. The average national average, 0.7, not even 1 full point students got on that APFRQ out of 4 points. So that was not good. So we want to make sure we've got power down. So let's take a look at this, and I want, somebody's going to tell somebody something. Okay, so get ready for the question. Where is the power on this picture? Where is the probability that you will reject the null hypothesis if it is indeed false? Where is the probability that you will reject the null hypothesis if it is false indeed? So let's see who tells it. It is odds again. Odds, tell the evens. Where is power? Power is the probability to reject the null if it's false indeed. Dun, dun, dun. Okay, power is the probability to reject the null if it's false indeed. Okay, I think you're coming up with it. All right, so let's see. Odds told evens, so evens tell me. Miss Maddie, who's even over there? What did they tell you? You can blame it on them. Okay, what'd you come up? Ding, 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 ding. All of this are the samples and the proportion of data that will lead us to reject the null hypothesis if it is indeed false. Good job. That is power. Power is the probability. Does anybody know what tune that is? To reject the null. To reject the null if it's false indeed. Dun, dun, dun. Power is the probability. Doom, 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 doom. To reject the null. To reject the null. If it's false indeed. Any ideas? Hotel California. Yay. Okay. So I know. Because of my recording situation, I'll have to wait until I'm done recording to actually play it for you guys. So we'll go back and we'll play our little. Oh, I can hear it in here. It sounds so good. So you'll have to miss out. Okay, but I'll pull it up and play it for you in a little bit. Okay, so let's then talk about what's happening. What if alpha gets bigger? Okay, if this alpha right here gets bigger, which direction is it moving? Over here, what happens to power? Will power get bigger or smaller? Bigger. Power will do whatever alpha does. So whatever this arrow is, on the left, we use that word increase to describe what's happening to power. So this picture is about increasing power. If I make alpha go up, power increases. If type 2 goes down, power increases. I'm wondering now, I think it's Evan's turn. Let's have the Evans tell us, think, don't say yet. What's the relationship between power and beta? What's the relationship between power and beta? Okay, go. Evans tell odds. There's a number involved, FYI. There's a number involved. Okay. Power plus beta is what? 100% of the data. Whew. Power plus beta is 100% of the data. Whew. Okay, so there's our thing on the next page. So there is that numerical correlation. And so today was something new that I came up with, which was just that. Oops, that's wrong. Power plus beta is 100% of the data. Huh. Power plus beta is 100% of the data. You missed it. Huh. Okay. Power plus beta is 100% of the data. Okay. Y'all are wimps. Okay, I think we can do better. You ready? Power plus beta is 100% of the data. There we go. Okay, so there is our stuff. Let's move on to getting to actually use all the markers that you picked up today. So go ahead and pull these out. Here we go. All right. Okay, so listen up. As a researcher, listen. Shh, shh, shh. If you are the person hired by the company to go and collect data and you're a researcher, what things do you have control over? What are the things the researcher or the surveyor can control to affect type 1 and type 2 error? We know alpha. Good. That's one thing, and that's what we're going to talk about first. What else? No, you don't control beta. We don't control beta. You're going to go collect data. What do you go decide to do? Sample size. Ding, 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 ding. How many people are you going to survey? That is going to be the other thing we're going to talk about today that affects our probabilities. All right, so let's do this first one here. This is going to kind of be review, so this one will go quickly. Here we go. Changing alpha. This picture, we're going to increase. Okay, we're going to increase alpha. So you see the size of these, of the top and the bottom halves of this picture do not change. Okay, so you have this in your packet, so you can find it, and we're going to be coloring on it. Yep. Okay, so the pictures do not change. The sample size was the same on these. So let's draw a 5% in here, alpha. I'm going to purposefully not put it right at the little crosshairs because I don't want you to get a misconception that that's where it goes. So there's our alpha equals 0.05. So here, if the null is true, then this is the probability of a type 1 error. Okay, now let's draw it down below, but bigger. So I'm going to say 10%. Alpha is 10%. So as a result, what has just happened to the probability of a type 1 error? Good. Probability of type 1 error has increased. Okay. All right. So on all of these things, I'm going to use the same color. I'm going to use red to represent my alpha, the rejection region. Okay. You can do whatever. Wait, I'm going to make, okay, what? What was your question?
We're supposed to do that in marker and color?
That would be good if you did it, yeah. That's kind of what it was intended for, yeah. We're on markers now. Okay. See, and your piece of paper has nothing on the back of it. It's just a one-sided, so that way the markers don't bleed through and mess up information on the back. I know, smart. Okay. So now, what is happening over here? This review, we know what's going on over here. The probability of our type 2 error. So I'm doing mine in blue all the time. Type 2 is in blue. Okay. So what happened when type 1 went up? What happened to the type 2? It went down. So type 2 error decreased. Okay. 1 goes up, 2 goes down. Always, always. Okay. So what's the third thing I'm going to put in here? Power. You're going to use your highlighter for power. So let's do it. Highlight the probability of rejecting the null if it's false indeed. Power is the probability to reject the null. And then y'all are going to repeat after me. To reject the null if it's false indeed. Good. Power is the probability to reject the null. To reject the null if it's false indeed. There you go. So what happens to power as alpha increases? Power increases. Power increases. I know it's hard for you to imagine the song, but I hear it in my head and it's so pretty. Okay, you're missing out. Okay, so real quick, we'll go ahead and draw our little thing that we know so far. Type 1 is alpha. Type 2 is beta. And as the left goes up, the right goes down. And these are the ways to increase power. Okay, so that's the start of it. We're going to be adding to this picture still. There's our little shortcut writing thing. Okie dokie. So now, here's our little shortcut remembering device. Let's do the next page. Are you ready? So the next page is the other thing that researchers can control. And what is that? Sample size. So taking a look at these two pictures, I didn't really draw the bottom one quite to scale. It should probably be taller because they look like they have different amounts of data in them. But anyway, but based on the what I was trying to have you visualize, what happened to N from the top picture to the bottom picture, and how do you know? Don't say it out loud. I want you to think in your brain what happened from the top picture to the bottom picture, and what is giving you that indication. So let's see. It is the odds again. Dang. Okay, odds. What happened from the top picture to the bottom picture, and how do you know? Okay, so what is it? Larger sample size. How do you know? Margin of error, yeah, sort of pretty much, but it's less varied. Less varied. The data down here is more closely clustered around the center. It kind of sucked in the data and put it closer to around the middle. So N is increasing. That's what we're doing on this page, increasing the sample size. Now, incidentally, so that we only see the effects of N, we are going to keep alpha the same. That's important to note. I don't think they would change both at the same time unless they say which one provides, I don't know. Okay, so we're going to increase N, so we're going to keep alpha the same. So let's go ahead and draw an alpha on the top of 0.05. Alpha equals 0.05. And it will be hard to tell, but try to draw a 5% picture on the bottom also. Probably needs to be more like that. So I attempted to keep alpha the same on both of those so that we're just seeing the result of the sample size effect. That would be confounding variables. If I changed too many things at once, you couldn't tell necessarily what the pure effect of one thing is. Okay, so there's our type 1 error. It stayed 0.05. Let's put our type 2 in there. Up top, here's our type 2. My type 2 is in blue. And let's look at it down here. What's up? I don't even know if there's any data down there. It's not necessarily going to go to nothing, but it's very obvious that it did what? Yeah. Type 2 error decreased for sure. Okay, type 2 error decreased. Alpha stayed the same. So what did type 1 error, the probability of a type 1 error do? The probability of a type 1 error stayed the same because I kept alpha the same. Okay, now what do we put in here? Power. So highlight your power. Power is the probability doom, 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 to reject the null, to reject the null if it's false indeed. Doom, doom, doom. Okay? I know it's building up the excitement. So what happened to power if that type 2 went down way bunch? It's kind of hard to see because it's not drawn to scale, but the power increased because power plus beta is 100% of the data. So therefore, if the power went down, then if beta went down, power went up. Yes.
So, can we measure it like this?
No, it's just going to be all of this. It's just this is 100% of the data
Okay,
still.
so
Yeah.
kind of
It's
this
just
area.
all those samples in HA. All the samples in HA. Okay. So now we're going to do our little helpful device by let's start her up. Type 1 is alpha. It's in the circle. Type 2 probability is beta. But we're going to add something down here below it. Okay? We're going to add N because that's the other mechanism. Well, that's the other item we're controlling. Now, statistically, N is affecting the what? Well, yes, I mean, but like, what made this skinnier down here? The standard deviation changed. Okay, cool. So the sample size was affecting the standard deviation. Okay? All right. Now, let's discuss. So N went up. Okay, what about alpha? Okay, so because alpha stayed the same, then I'm just going to, there's no change. So whichever item, so there's two circles, these two circles that you as the researcher control. You control this circle and you control this circle. So you're going to cross out, I mean, if you keep one of them the same, then cross it out. You know, if sample size stayed the same, you'd cross that one down there out. Okay. So keep that in mind. Cross out the one that doesn't change if there's one that doesn't change. But what did we do on this page? We made N go up. And when N went up, it made the type 2 and standard deviation go down. And what did it do to our power? Increase. Whatever arrow is here on the left is what's the word? Increase. Power is at the top. So there's our little remembering device in its completeness. And we'll get used to drawing that out. Okay? And so that's the end of our learning today, how important it is to know what affects those errors. Now, let's hear our power song, okay? So we have no homework over the weekend, yay. And then we'll finish this up on Monday and quiz Tuesday.